Hi guys, today we're going to be talking about polynomials, and this video is just going to introduce you to polynomials. Now the word polynomial is broken down into two parts. Poly, which means many, and nomial, which means terms. Your first question is going to be, what is a term? If you have a polynomial, I'm going to write a very generic one here. 4x squared plus 1. In this polynomial, 4x squared would be considered a term and plus 1 would be considered another term. And so essentially a polynomial is made up of multiple terms. It can be one or it can be many. Each term in a polynomial, so I'm going to write, okay, let's just say we use 4x squared. There are three different parts of a term. The first part will be this number you see in the beginning of the term. And this is called the coefficient. The next part will be whatever letter you see. So in this case, it's x squared. And this is what we call the variable. And the last part will be the number that you see on top of the letter. And this is what's called the exponent. So every term in a polynomial will be made up of these three parts. Let's say you have a situation though where you just see 4x. You might be asking, what is the exponent? Well, on things like this, when you have x with nothing on top of it, there's actually a 1 that you're not seeing because they don't think it's important to put the 1. But there's still an exponent on this x, and that exponent is 1. Now, a polynomial has three main parts. The first thing that it has is a constant. So in this example that I gave here, the constant is plus 1. And so a constant in a polynomial can be any number. It can be 4, it can be minus 7, it can be 0.3, it can be pi, it doesn't matter. It's just a number. The next thing that a polynomial has is a variable. And that variable can be x, it can be y, it can be z. It can even be a, it can be b. A piece of advice I would give you here is don't get tied down to whatever letter your teacher uses as a variable. It really doesn't matter. I would say that if you think it's a variable, as long as it's a letter, it's probably a variable. And the last part of a polynomial is the exponent. And this is what actually is going to be probably the part that's going to trip up a lot of people. Exponent in the polynomials can only be positive whole numbers. And this is important. So this means that you can only have numbers such as 0, 1, 2, all the way up to 1,000 if you would like, but no negative numbers. So that means that you can't have x to the minus 4, or you can have x to the minus 10, not allowed. And also no fractions. So you can't have x to the half, or you can have x to the minus 1.5. These are not allowed. You can only have positive whole numbers. Here are some examples of common polynomial graphs. So you can have a straight line graph, or you can have a quadratic graph. You can have a cubic function, you can have a quartic function, or you can have a quintic function. And what actually makes the graphs look like this is the degree of the graph. The degree of a polynomial is the degree of the highest exponent in the polynomial. So for example, let's say I had a polynomial like x to the 5 plus 2x to the 7 minus 1. Here, the highest exponent of this polynomial is x to the 7. And so that makes this polynomial degree 7. Same thing, if we had another polynomial, let's say 3x squared minus 21 plus 50x to the 5. Here, the highest degree in this polynomial is not x to the 2, it's actually x to the 5 here. And so that means that this polynomial would be degree 5. Two concepts that are important to know, and I think you should know right off the bat when it comes to polynomials, is the concept of intercepts. Now, intercept actually means to cross. And so the x-intercept is where your graph crosses the x-axis, while the y-intercept is where your graph crosses the y-axis. The x-intercept can also be called the zeros of your polynomial, and it can also be called the roots of your polynomial. So whichever one your teacher uses, they all mean the same thing. If we look at this graph right here, the x-intercept is the place where your graph crosses the x-axis. So on our graph, that would be here, and it would also be here. So these two places would be considered the x-intercept. A quick way to find the x-intercept, if you have a polynomial equation, is this is where your y is equal to 0. So if we look at this graph, at these two places, what do we see? We see that y is 0. And so your x-intercept is where your y is equal to 0. For the y-intercept, it's usually just called the y-intercept. To find this, this is where your x is equal to 0. And so if we look at this graph here, we see that this is the y-intercept. And if we look up, we see that here, x is equal to 0. So essentially, if you want to find the x-intercept or you want to find the y-intercept, just set the other variable to 0. You may be asked by your teacher to put your polynomial in standard form. And all they're asking you to do is to arrange your polynomial from terms with the highest degree to those with the lowest degree. Putting your polynomial in standard form is not actually required to solve polynomial equations, but I find that if you always put your polynomial in standard form, it might make questions a little bit easier. So here we're going to put this example polynomial in standard form. And the first thing you have to realize is that a term, negatives are part of your term. So for example here, minus is part of this minus 91x to the 7 term. And so wherever the 91x to the 7 goes, the minus has to follow. If we want to start here, the highest degree is actually 7. So here. So x to the 7 would be the highest degree. And then x to the 5 would come next. X to the 4 would come next. And in constants, they're actually degree 0. So here, this would be degree 0. And so it would come last. So if we're going to arrange this, we're going to actually number how we're going to write it out. So this term is going to come first, then this one's going to come second, this one's going to come third, and then this one's going to come last. So if we now rearrange this equation in standard form, what you're going to have is 91x to the 7, always take the minus with the term, minus 2x to the 5 plus x to the 4 plus 2. And now we've put this polynomial in standard form. These are a few practice problems, and I would suggest that you pause the video and try them for yourselves. And I'm going to explain if these equations are polynomials, and if they're not polynomials, why. The first one is x minus 9, and the two terms here are x. There's nothing wrong with that. X to the power of 1 is perfectly fine. And the next term is minus 9. So that also looks good. There's nothing that is a red flag for me to think that it's not a polynomial. So yes, this is a polynomial. The next one, question 2, 4x squared looks perfectly right. The 2 is a positive whole number, so that's okay. The next term is minus 27. That's a constant. We know that that's part of a polynomial, so that's also okay. But the problem arises when we get here, when we get to this square root of x. The square root of x can also be written as x to the power of 1 over 2. And what do we see? We see a fraction. So this is a fraction. In the beginning of the video, I told you that the exponent of, or the exponent in a polynomial must be a positive whole number. So that means no fractions allowed. It has to be a whole number. And here we don't have that, which means that no, this is not a polynomial. Question 3, 2 over x. Now, when x is at the bottom, it might get a little confusing. So what I would suggest is putting the x at the top. So if we take this x to the top, this equation actually becomes 2x to the minus 1, because when you take x from the bottom to the top, you have to add a negative to the exponent. So here, this 2x to the minus 1, because the minus 1 is actually not a positive number, and we know that the exponents of polynomials must be positive whole numbers, this actually means that this is not a polynomial. Here we have a constant, and that's okay, because constant is part of a polynomial. So yes, this is a polynomial. And the last part is x to the minus 4. So for exactly the same reasons as question number 3, because we have minus 4 being the exponent and this is a negative number, it means that no, this is not a polynomial, because the exponents of polynomials must be positive whole numbers. In my next video, I'm going to be covering addition, subtraction, and multiplication of polynomials. So make sure that you hit the notification button so that you know when that comes out. And also like, comment, and subscribe. And specifically comment any topic that you would like me to cover.